Good evening, dear participant, and welcome back to this session on longitudinal data analysis. And today in the session, our resource person will be Dr. Mahaveer Singh Panwar, Associate Professor, DST-Centre for Interdisciplinary Mathematical Science, Banaras University, Varanasi, Uttar Pradesh, India. So before inviting him, I would like to have a brief introduction. Dr. Mahaveer Singh Panwar is an esteemed associate professor at the DST-Centre for Interdisciplinary Mathematical Sciences, Institute of Science, Banaras University, Varanasi, with a robust academic background. Dr. Panwar completed his PhD from Banaras University, focusing on Bayesian inferences for conserved data from the Maxwell distribution. He has also earned an MPhil and MSc from Chaudhry Charan Singh University, Meerut. His career has been marked by the progression through various academic positions, beginning as an assistant professor at the Central University of Rajasthan and the Central University of Punjab before joining Banaras Hindu University. Dr. Panwar's research contributions are extensive with numerous publications in reputable journals and ongoing research project. He has successfully guided several PhD scholars and is actively involved in interdisciplinary research projects, particularly in statistical modeling and disaster risk management. His dedication to academia and research is reflected in his sustainable body of work, which continues to impact the field of statistical sciences. So once again, I welcome to our research person in this session and welcome to all the participants for joining this session. Now, over to you, dear professor.
Thank you, Dr. Mahaveer, and very warm welcome to all the participants as well. And once just check that I'm audible.
Yes, sir, you are audible.
Okay, great. Let me just check by sharing my PPT. So here it is.
Perfect visible,
is
sir.
Is it visible?
Yes, sir, visible.
Thank you. Okay, slide. Okay, so good evening, everyone. As Dr. Mahaveer just introduced the things about today's session. Today's our session is on the introduction of longitudinal data, and we will give some basic examples and coding of longitudinal data with the real life observations on the R software. So I'm Dr. Panwar, Associate Professor in Banaras University. Just a very quick look about the data before we just go into the coding. Actually, if we will say longitudinal data is not as usual studied in the particularly in statistics. In when we go with the advanced studies or in the advanced research, then only it will utilize just because of some complications with that data. And today we'll try to identify to understand what it means and how it works and how it is useful for anyone, not even a person who's in the background of statistics, either he's working in the psychology or in the physical education or in clinical trials related data or life sciences scholars. So this data is in general identified in many more situations. So let me start with the basic what we are going to cover today in this lecture. So there are so many things if you will see in the contents, but it is actually necessary that we will start from the very beginning. I'm quite sure that most of us are not very used to with that kind of data. So let's start with the beginning. First, try to identify what is longitudinal data, what are the advantages of such studies where we are just going with the longitudinal data. Of course, there may be some disadvantage at the same time, and with some real examples, we will demonstrate all these things. Then we will try to find out what kind of structures of longitudinal data, if we are going to any kind of data collection, then what kind of frame is required. Then we will see some basic examples and data available in the R software. It is already by default some data sets are available there. And then lastly, we will go with some statistical methods. And I'm just specify here, we are going with some very beginning level models which we utilized to understand the basic structure and their estimation or their inference. And if someone is interested to higher level models, then there are a number of models are available in the research or in the literature where we can go for that. But today's lecture, we will just try to find out how we'll utilize the things available in longitudinal data with the help of some statistical methods, which are possible by very big beginning level, fundamental level. So before starting this, again, I will say that it's kind of interactive lecture. So anytime if you think there is any issue or doubt, you can just ask me at the same time. And in the beginning, we will start in very slow pace, and after maybe that will be possible that we will go a little bit quick. But the point is, if we start, what is the longitudinal study is? So in general, in a very simple words, we say if we are repeating our observation on the same individual over the time, 2 times, 3 times, and 4 times, like that. So in that case, in general, longitudinal studies are developed. So that kind of studies are also done in other framework where we just go to some person and they collect the data. But actually the characteristics of longitudinal data is that in that data we are just going to individual person again and again, or we are simply saying we are repeating our experiment. So that's why we are saying that repeated observations are collected for the same variable or same individual. Okay, so for the same individual, we are just going 1 time, 2 times. Sometimes we can't kind of follow the studies. A doctor or patient to visit to the hospital for number of times, and all the times we just collect some reports from him about some particular, collect about some particular parameters. Then this is kind of, we are just taking the same variable, kind of say we are just collecting the blood pressure measurement after 1 week, and then again 2nd week, 3rd week, 4th week. So means for an individual, we are considering a variable like blood pressure over the weeks. So that data is somehow comes under the study of longitudinal study. So if we just go in the history, that study was somehow attributed by Francis Galton in 19th century. And he just conducted a kind of experiment, if you will see, in that he just developed a hereditary tracking characteristic like high intelligence across different generations. So generation to generation from the same family, he just collected that data and he tried to establish some results or estimation on the behalf of that. So we just find out a particular individual, that may be kind of particular person, that may be particular in some time family or like that. So for that, we are just take the observations again and again and over the time. So that is the simple basic structure, or a very simplest way we can define the longitudinal data. So it is highly effective technique for modeling changes over time. The overall purpose is on those all those experiments where over the time the situation is changing, the impact is high, number of variables are available there. Those are impacting the or affecting the individual's variables, that are all just measured or observed, and then we just inference on the behalf of that, and then we can say about the outputs or conclude about the particular say time-based variable or response variable in which we are interested. So that is the overall structure of longitudinal study, if you will say. And if just go, what are the advantages, why we are doing this, how it will be helpful to inference something about. So the point is, what the main point or main character is, that it allows researcher to observe changes and development over the time in the same subject. Say if we are just going week by week or day by day or say monthly basis data we are collecting for a patient, so we can just identify what kind of improvement or decrement is we are following in his or her health. So the point is, we are just taking the changes and accordingly we plan. Accordingly, a doctor may plan what we can do with that particular patient. So the point is, over the time, the changes are observed and accordingly the inference is done, according the treatment is done. and the same time we are just getting some relationship in the different variables and on the response variables, and we identify that what particular variable is impacting more the response variable, then we treat that particular variable first, and that's why we just control our response variable. So that kind of facilities the longitudinal studies give on stage by stage or time by time. We just continue our experiment. Of course, it reduces the recall bias. Recall bias is that sometimes what in some experiments we just reach to the person and just ask about any incident or any particular variable in which we are interested, but that is already happened in the past, so he is not exactly able to recall that event or about event time, about the reactions or the features of that event. So in that case the data is always biased. But in this case, when we are just going a particular person at a particular time, and at that time we just ask about him, what is the situation? So there is no such chance of non-recall at that time. So whatever be the position at that time, he just give the data accordingly. So recall biased point of view, we say we can reduce this at a very large level. At the same time, it give a personalizing insights for each individuals. We are just tracking each individuals at different time points. So there is a great insights that in detail he will give information about whatever the response variable and related variables. So all these things comes together in the longitudinal study, those kind of advantages it will say. And then once we just get the data, so in that data there are a number of variables we consider. So in that case many other studies which can utilize that data in form of secondary data, and other outputs or conclusion can also be done basis of that data. So depends upon the framework of that. So these are the basic advantages if we see in the longitudinal studies. But at the same time, if we will say there are some disadvantages with associated with this. So that's why just because of these factors, we avoid to go with the longitudinal data. Even though the advantages of that, the first thing is it is time consuming, of course. If we are following a person or following a patient or individual over the time, then it will be of course going to be time taking, number one. So and of course we know as much time we just reach to him or her, that data will be more informative or inference will be good, but of course it will be highly time consuming. And the second thing is cost is again very high. So no doubt once we are just following again and again, so all the time the person those are associated with that experiments, so the point will be the cost associated with the labor in terms of time, in terms of fuel, in terms of so many things attached with the surveyor point of view. So the cost of this experiment or to get that data will always going to be high. At the same time, if we'll say that, of course, participant iteration will be over there. If you are just going to a person or individual again and again and asking about something, then of course he will feel that kind of iteration will be there. So we will try to avoid that, of course, in the surveyor point of view. At the same time, complex data management, we are considering the response variable, then the independent variable, those are associated with this. We are considering different time points, different follow-up points. We are going with that. And if there are a number of individuals involved in experiments, say we are going with any such individuals. So in that case, overall structure will be multidimensional. And in that case, a person who is just noted down those things, who's just going with the analysis of that, so that whole thing will going to be complex. Okay, so and one more thing is that it's not possible that all the time all individuals at all follow-up times will be available. So these things make it more complicated. For few individuals we have all follow-up time points, but few individuals for some other maybe there's maybe sensor. So we will discuss about that in the next slides. And the last is, of course, there will be a confounding variables available, chances are very high. So these are some basic things we just consider as the disadvantages of longitudinal data. But overall, if someone is interested in a particular study in which he is expecting a high level of inference with high level of precision, with less bias, in this case, the longitudinal studies is very useful. And in these days, if we'll see in respect to the last century, if you say, the data management is quite easy. We have so many tools to collect the data. Digitally, you can arrange the data, or you can go with some mailing system, email through email or through apps. We can collect the data. So nowadays, it is simpler or easy to collect a longitudinal data in respect to the last century. So that's why just because of these changes, the chances or the working structure on longitudinal studies are time to time are getting simpler, and many of new studies are just behalf of longitudinal studies are coming into the picture. So the point is, this kind of data is not just belongs to, if we will say, if you particularly say, not just on the medical field, you will say a lot of work on the longitudinal studies done on the psychological based data, where the individuals or the persons are just come again and again with their reactions or their characteristics, and a particular who is just treating them, or a person who is just counseling him or her, he simply noted down that, and on the behalf of they just go to the counseling and many more things. So the point is, in if we just conclude the last 2-3 slides, we will say we are following an individual over the time, and accordingly we are collecting response variable in which we are interested, and at the same time we are collecting some other variables which are considered independent, and we are expecting those variables is somehow going to impact our response variable. So if you will say what I'm saying, in that case, of course, we will try to see what kind of examples are real life is actually which just match with that. So the thing is, it is time taking, but the data is actually that fine or that good that many of the studies have done on that. So one of the example is the Birmingham Heart Study. So that study was initiated by 1948 by the National Heart, Lung and Blood Institute. So in this study, what they have done, they just take it is based on the cardiovascular disease, and what they have done, they just involve initially 5,000 adult residents in that city, and what they have they just collected their data based on their health matrices, and they collected a number of other variables. Those are somehow, we can say, connect or impact that kind of disease. So that may be including blood pressures, cholesterol level, smoking habits, or also physical activities, what kind of physical activities they do in their day, or connected with their work. So point is, they collected that data over the years for individuals, and on the behalf of that, they just plan or shape the public health policies for the city or kind of the public. So that is helpful for a government, or say organizations. Those are working behind them, who are involved in the say supporting them in terms of financially or health management system. So in all those situations, the study of that kind of data is helpful for everyone. And if you will say, they started this in 1948, and it is still continuing. What they are doing, they are just ongoing with that study, and now including participants from the third generation. So for the same family, they are just going to the third generation with the same kind of variable. Those are associated, and then they are trying to identify how the cardiovascular disease are just rising, or that particular individuals or families. So that is the if we will say, the benefits of the longitudinal data. Over the time you are just going with that and trying to find out. And many organizations, not just government, many health organizations are involved with that data, and then trying to identify or resolve the problem for such families or such generations. They make a overall inference about that. And a similar example, if we just say, is a very famous British cohort studies. In this study, they a number of national organization of British UK is involved in that. They started with the 5,000 participant in the 1946, and then what they have done, they see the utilization of that particular experiment. So they increase the number from the 17,000 to 16,000 participants respectively. So more than 30-40,000 participants in of that country in that experiment. And the key area of including what they are trying to find out, they are just including educational attainment, health outcomes, employment history, social behavior, and family dynamics. So all those things are considered, all those variables are considered, and then they are trying to find out how to count kind of impacts of these variables are given on their early life, later outcomes, and how these things will lastly impact the overall lifespan of a person. So then, of course, what we have said, including these effects, the socio-economic status, education, the health of life trajectory, that all are just measured over the time for all those individuals. Those are considered all those participants in that subject. So that kind of track actually can be identified, and accordingly we can go with the results or conclusion for those persons and all those persons which are associated like the same scenario. So what they have done, they are just tracking the participant now, including their children and grandchildren, to explore intergenerational impacts of evolving life outcomes. So that's what I'm saying. It's not just a clinical trial, not just on the purpose of health management in the system. The point is, on the behalf of the past generations, what we are trying to do, they are just collecting all those data for different outcomes that may be just belong to health, that may be social economic status, education play important role, and so many variables involved in that study. And on the behalf of that, they are just trying to projectile what will be happen to the next generation of that person. So all those things are covered in that kind of a study. So the point is in longitudinal studies, sometimes we just see in the very first instance that it is quite huge, data is complex, it is time taking. But lastly, of course, the data is so good, we are following a person over the years and the results are so fine, and all kind of, if we'll say, decision making, that's why this data is utilized, and the use of this data is increasing day by day. And the behalf of that studies, we can somehow, if we'll say, make a more precise decisions. The next third study, I'm just considering these studies, those how somehow identifying the different scenario of the life, not just health management, we are considering the social impact. And next is, say, in the financial point of view, we will say it is a kind of panel study. We will take the difference, how it is a panel study somehow comes under the longitudinal study. So it is a panel study of income dynamics, and it is conducted by the United States from the 1968. So they follow the 18,000 individuals in their discriminates. They track their income, their wealth, their employment status, their health, and expenditure over time. So they are just collecting their data, and then they are providing how the impact of education, the policy on financial well-being and response to economic shocks for all those generations over the time. So my point is, this is of course time taking, again I'm saying, but the results, the outputs, and the decisions those the organization are taking, yeah, and an experimenter can take on the behalf of longitudinal data, that is marvelous. So that's why we can just go with the longitudinal study. So this is the simple basic examples, but the thing is how it's look like, we of course we have to go with that. Again I'm saying the data is looking quite complex in some way, but if we will see the structure of this overall point of view, you will find out that in longitudinal data, the term is we are just going with the same subject over the time. So how we'll try to identify, let me check that my pen is working on this. Yes, just 1 second. Okay, it's not working. So let me take a pen. Okay, so point is, what we are trying to do here is, in this subject we consider a subject that we consider a subject 1, and for that particular subjects what we are doing, we observe the observation for that, or we just follow that particular observation and 1, 2 and n1 time points. So for each person we are just going n1, n2 and different time points. So that is the general scenario what we are doing with the individuals. So again I'm just saying, what we are saying, we are just following a particular person. So subject 1 is here, for that person we are just utilizing the thing, and for this person we are just follow up n1 times. For first person we just follow up n1 times, For second person, we can go with the n2 times, then n3 times, and so on. It is in basic level of longitudinal study, we go for each patient or each individual for equal number of times. That makes our data more balanced. And how the response variable will look like, whatever be the response variable you have. So in that case, variables, that response variable, the variable of interest, is somehow looks like y11, y12, and y1n. Means for first individual, we are just going n1 time. Okay, and then accordingly for first predictor, if we will say, whatever be the independent variable or the predictors in general we call in the statistics, those are somehow related to the response variable or help us to identify or to estimate about the response variable. Those are simply the predictors. So in this predictors, we are say considering the p different predictors are involved in that study. So the first thing will be x111. So x1 defined for the first individual, we are going the first predictor for the first time for the first individual. That is the meaning of 1 1. So if you're just going to the x2, x1 2 1 is, that means we are going here with the first predictor, second follow-up time for the first individual. So that is the meaning of x1 2 1. So that's how the data is collected in this way. So if we just go with the some other predictor, so what it means, what x1 2 p means the value of the pth predictor, if you're just going with that at the second time point, second follow-up point with the x1 x with the first variable. So that's how it is working overall in this data. So all observations are collected in the same way. So overall or general, if we will say, the structure will be look like this, but in particular we will say sometimes in a clinical trial what we'll do, we will fix a cohort of n observations. Say there are a fixed 50 patients in particular clinic or particular ward, and then what we are expecting that we are going to that person per day for next 7 days. So like that, in that case, for each patient, we are considering the response variable and all the related variables, predictors for per day to the 7 days. So that kind of data is simply structured data. There is no imbalance in that kind of data. So this is the general form, which we can see in the through an example in the R, and then we will go with the say modeling for that particular. So that is the structure of longitudinal data, which in general utilized in all kind of studies. So if we just go through this, you can able to identify. The point is what we have just studied or just discussed in the last few slides. The term is that most of the time that kind of a study where we are just going number of times per person is somehow we just listen in other data sets available or studies available in the statistics are utilized. So how it is different from that? The first one is the cross-sectional data we generally utilize in the demography point of view. So how it is different from the cross-sectional data? So we just try to make some differences. The first is in the cross-sectional data collected at a single time point. So this is a simple demograph or a simple structure I just plot here. So in that what we are doing, the time is fixed. We are just going to different individual at the same time point. So data collected at the time point. So that's what it is written here. The collect at a single point in time. Collect over multiple point of time. But in longitudinal studies, what we are doing for the same individual, we are just going again and again and again. So that means we are just multiple time points, we are observing the data. So that is the basic difference between the cross-sectional data and the multiple data. So in this phenomena, what happened, the snapshot of population of phenomena. So what will we have in the cross-sectional data? We just take some observations, and on the behalf of we are just going to study. But what happens before that and what will happen after that, that is not in the point of our study. But in case of longitudinal study, what is happening? If we are going different time points or follow-up time points, what will happen? We can track, we can identify the track at what way individuals are moving during that time. So if we are tracking a person 2, 3, 4, or 5 times, so in that case, of course, there will be a track over for the response variable on the behalf of predictors or independent variables. So that track can be identified. So that is the basic advantage between the of using the longitudinal data instead of a cross-sectional data. Of course, it is useful, as we will say, useful to pattern, correlation, and comparison, useful for development, progression, and cause-effective relationship. So the point is, over the time, what kind of development or progression in the data that can be identified with the help of longitudinal studies. So that is the basic difference of cross-sectional study and longitudinal study. So these are the advantages. Of course, low cross-sectional study is less time taking, longitudinal study will be a little more time taking. But accordingly, we get the results. We get the better results in the longitudinal study for each individuals. And at the same time, what we are saying, if we just go to the next one, that is the difference between cross-sectional data. Again, there is a different study, or called, we just say, the panel data study. So actually, if we will say panel data follows more detailed analysis because it includes multiple entities. It's just not going the particular individuals. So it's enabling comparison both across entities and over the time. So both two, if we'll say variables are considered, yeah, two dimensions are considered at the same time. Whereas in longitudinal study, what we are doing, as we discussed earlier, for individual level data collected over time. Whereas panel data, again, we are saying typically involve a data set with multiple individuals observed across multiple periods. Okay, so it is going to check the multiple individual as well as particular individual over the time. So we generally say all longitudinal data is a panel data. So if we just multiple individuals are just reduced to the one dimension in particular individuals in place of multiple individuals, so that it will reduced to the longitudinal data. So we say the all longitudinal data is panel data, but not all panel data is a longitudinal, of course. So this is the basic difference between the panel data and the longitudinal data. So some other data is also available, say time series data is there, and so many data structure is available that is defined on the behalf of time. But there is some differences. Some are quite major differences. Sometimes it is quite minor differences in terms of based on time. But longitudinal data is we just gave last time it is that longitudinal data is for each individual considered in the study. We just go multiple times and we collect the response variable, the variable of interest in which we are just going to study or analyze on the basis of some other variables which are considered as the predictors or the variables, independent variables. Those will help us to inference about the response variable. So this is the overall, if we will say, introduction of the longitudinal data. Now the point is how these data are available in somewhere in some other sites, or if we just try to understand the structure of that, how they are look like. So I just find out there are a number of longitudinal data are available in the our software. A basic example is of real data. R is say orthodont data set build, that is under the NLME package. And this data is a longitudinal measurement of dental growth of child measured through their age in years. Other data is available. Investigators of the investigators from a dental school full of 27 children, they get that data. Every 2 years they are the amazing. So there are a number of data sets available. One of that is the orthodont, and many others are there. So you just once search the longitudinal data in the R software, there are specific packages are also available in which only the syntax is developed on for the longitudinal data study. So there are also the different data is also available there. So in R, there is a lot of work has been done and number of packages are available, particularly for the longitudinal data studies. So we can go through that. If we say for that particular data, we just consider, so there is a library. I'm not just switching to the R software right now. We will go to the last and just we will see how it is working through. So there is you just of course go with the load the package NLME, of course that will be available there. And if you just go with the head of that orthodont data, so there is a distance, first variable is there, age is also there, subject is defined there, and their sex is also available there. So if we will see what is happening in this data, that our response variable is the distance, and then the age is considered for subject. So here if we will see that the first subject, it is indicating by M01. So that particular subject is here. And for that particular subject, 1, 2, 3, 4, 4 different time points, the observations are collected for that particular person. So that individual or subject, whatever we'll say. And at the time of the difference of 2 years, at the age of 8, at the age of 10, at the age of 12, and at the age of 14. And the gender, this find out that is male, and the distance is calculated over the time is 26, 25, 29, and 31 for the first patient. So this is the data, and in this data, of course, the number of children they considered, and accordingly they have just collected that data. So this is the structure of a longitudinal data, where we, if we just try to match our definition of longitudinal data with this data point, we will say for an individual, the 4 different time points, the observations are collected, and accordingly the size of say M2, M3 is the number of individuals involved in that study. So this is basically or simply the part of that. Okay. So this can be visualized with the thing that how it is working, and how it will how we are going to see a longitudinal data, or in our study accordingly we just try to identify the response variable, and accordingly we are just going with the predictors. So in next way, this is the simple plot, the simplest plot, while we just take the track for that data. So if you will see, we have done just nothing in that. We just simply take our observation. This is orthonorm. We are using the ggplot command, and we just define our axis like x. On the x-axis we are considering age. On the y-axis we are taking the distance for orthodontic growth, and the third we just define the color. Color is defined on the basis of their sex, either she is male or female. So, and the last, the group of all subjects are over there. Then we just consider that we are showing the line and we are showing the point with the help of geom line and geom point, and labels accordingly. On the title we are saying orthodontic growth data. On the x-axis we are taking age. On the y-axis we define distance, and we just consider the theme minimal. So in this point, now let's see how this data is working. If we just find out any one of that, say there is an individual. So at the age 8, the value of that response variable distance is this, and then over the time 10, 12, and 14 years we can track how it is increasing. So now we have the 2 queries in the longitudinal data for which we try to identify, or on the behalf of that we just go with them. If we will say the study, the first thing is for each individual you are getting the observation over the time. So of course you can identify how a particular individual is responding over the time. That is one thing. And second thing is, in a very basic way, we can say how the overall group is working. What is the overall growth? So these 2 factors or 2 ideas come in our mind in the very first look of this, if you will say, this plot. Of course, we can go with the gender-wise study at the same time, but right now our focus is that we are just saying these factors will be involved for the response variable. But the point is, we can see how a particular individual is behaving as per its gender, as per its age, and at the same time how the overall this group is working. So there are 2 things which are the subject wise we are just going to study, and overall study we are going at the same time. So these 2 factors are involved, which we are just going to study, and for that we are just going to make some kind of statistical methods, or we are going to develop some models for them. So these are the 2 purposes for us for this study. So I think up to that point, if there is any issue or any doubt to anyone, he can just ask me, or otherwise I will just continue with that. So this is actually the basic structure, if you will say, in which what we are expecting that if we'll say how the data is looking like, how it is better than other things, what were the issues or complications with that data, and how it is utilized by the different organizations, either in US, UK, and many other organizations. And lastly, how it will be look like, what will be the structure of that data, and after plotting, how it will work. So till now, we just done up to that point. So, okay, if there is no such issue, then we are going in the next section actually, in which we are just trying to identify this. So in this is, the point is, we are interested some statistical method which are available for the study of longitudinal data. So by seeing the last, if we will say the plot, we can think that of course there is kind of pattern, there is kind of uh, uh, increment or maybe some decrement. So in that course, regression analysis come in the mind in the very first way. So here are some models those are using directly or indirectly the regression modeling and many other things. So we can utilize all those models for this longitudinal data studies. Okay, so we just identify the few. The first is say we just in general or on the basic level or the fundamental levels, we just go with the linear mixed effect models. And as we just written here, the linear mixed effect models, what done, it incorporate both. Fixed effects will be there and the random effects will be there. We will discuss both. What is the fixed effect model and what is the random effects model. And we are just mixing both. First, we just go one by one, and then we just go with the last in the linear mixed effect models. And the next one is a general estimating equation, GEM we generally say. And these are also focus average based effect, okay, population average effects rather than subject specific effects. So it just somehow condition the overall data. So we can even go with that also. The third one is which is highly utilized in the psychological fields, which is latent growth curve model. They are actually interested in that. And a type of structural equations is over there, SEM. The structural equation modeling is done over there. And they are interested actually the inter-effect, inter-individual effects and the intra-individual effects. Both kind of those are interested to identify. So means what is the changes within a person over the time, for a person over the time, and what are the changes for a group, and how we can just try to, if we'll say, utilize both the informations, stabilize both the information through modeling, and then we can conclude something about that. The other methods which are utilized are survival models. We just take the few things like Cox proportionalism on the previous lecture, in which these days in the last 1 or 2 decades, a lot of researchers are working on that, in which what they are doing, they are just utilizing both the studies, both the data. The one data is simply a time based variable which is calculated or taken for a particular individual. At the same time, which is simply called as lifetime data. So we are considering the lifetime data as per survival model, and at the same time we are considering the longitudinal data, where over the time the different parameters for individual is calculated or noted. So now what they are trying to do, they are just trying to analyze the lifetime data on the basis of longitudinal data. So that means those are utilizing the longitudinal data studies to improving their survival models. And of course, if we just including those factors which are somehow impacting the lifetime of a variable in terms of longitudinal data, so that will be, of course, give less biased results for the survival models. So that joint modeling is going to be very popular or already very popular in the last 1 or 2 decades, and a lot of researchers are working in that. At the same time, of course, we are just going with the linear models in the in the different models. Of course, if there is a non-linear relationship between the variables, then in that case and predictors, that of course our choices will be the non-linear mixed effect models. So in that case, if we just choose some other non-linear models that may be based on Bernoulli kind of studies or logistic kind of studies can be utilized in that cases. So these are some statistical models we just utilize as per the situation, as per the data, as per the nature of the studies. But here we are not going too many different models. We are just going to a particular one, and we will see how it is working. and how we will get the simple direct estimates from that using the R software. So our purpose is just going with the first model, which is a linear mixed effect model. So in this model, in linear fixed effect model, so before approaching to the linear mixed effect model, first we have to find out what is the meaning of mixed model. So in mixed model, actually, a simple terms utilized in statistics is, so mixed model is the mixing of fixed effects and random effects. So once those two effects are comes in a model together, then it is called simply a mixed model. So let me discuss about what is the meaning of fixed effects, and at the same time what is the meaning of random effects in a model. So let's just go with the simplest form is what is the fixed effect model. So he's just simply writing which capture the impact of predictors that are constant across subjects. So what we are thinking, we are not considering all those individual, all those predictors or all those factors, if we will say, those are impacting an individual level. So we are just conditioning them, we are just avoiding them, and we are considering only those constants or those predictors, those are overall impacting the whole group. So in this we assume the effect are same for all subjects or group. So that is simply a fixed effect. So it means that particular predictor is fixed for all the variables. So what the model is, simple regression kind of model. We're just taking yij, response variable, beta naught plus beta 1 xij, this is your predictor, and epsilon ij. Here you can see at the same model we utilize the regression modeling, where beta 1 is your, of course, fixed effect parameters for each xij. I means the ith individual, jth means the jth follow-up time. So this ij, so here we are saying for this predictor xij, over the individual, over the follow-up time, the beta 1 is same. Okay, so that's why we are saying it is a fixed effect model and it is constant across the subject. So over the subject there is no impact of that. So that's why we are called as a fixed effect model. At the same time, if you will say in the random effect, the thing is completely different. What is happening in the random effect? What we are particularly interested in the subjective specific variability. The point is, for a particular variable, particular predictor is impacting a subject in different way. So that's why a subject specific variability must be identified and must be captured by your model, which is not done by the fixed effect model. So somehow we can say it is kind of more modification of fixed effect or upgraded point of view, can say, or it will give better results in terms of say bias or MSC or standard or whatever you are considering for precision or for the checking the model. So in that case, what is the random effect? So in this, if you will say what we have done, the yij, of course, the variable, b naught I, intercept point of view parameter, and beta 1, b1i, xij. So if you will see here, what we are saying, for each individual I, there is a parameter b1i. So it is a vector of parameters. So what we are saying, that this predictor xi is impacting each individual with the defined parameter in terms of defined parameters b1i. So that is the actual, if you will say, if actually that predictor that variable is impacting the yij as per the diff subject, then in that case it becomes necessary that we utilize the random effect model. So these are the differences of the fixed effect and random effect that we are going to utilize in our modeling, and that what you are going to utilize in your longitudinal data. So we have to identify that which particular predictor have or impacting your response variable. Either it is impacting like a fixed effect model, or it is affecting like a, or it is like random effect model. So these two terms will comes again and again, and as per our expertise, as per our subject expertise or the research area expertise, it is the duty or it is the responsibility of the researcher or the experimenter that he just identify that with which model we are going to modeling the data, and for the before that he must be identify that a particular variable is working like a fixed effect model or it is impacting like a random effect model. So that then after we are just going to test it, or that after we are just going to any kind of modeling. So how those are impacting, if you will say, so in longitudinal model, if we say, as we just discussed earlier, we just going with the linear mixed effect model, of course, but at the last we are going with that. In the first, in very first, what we are going, we are just going the linear fixed effect model, and then after linear random effect model. So first we will see how for the same data a model which is linear fixed effect model is working, and how for the same data a linear random effect model is working. So then we will go to the linear mixed effect and how it is improving the results, how it is making our model more better or good, that we will identify in the third term. So the three things are divided in the one by one point of view. So we'll just go with the basic one. If for the same data we consider linear mixed effect, linear fixed effect model, and what will happen if we just go with the linear random effect model, and then lastly we will see how it is going with the linear mixed effect model. Of course, all models are defined in for different data set or for different predictors. So once we are just going with our data set or the data set we just collected, then in very first, I think you will understand that what kind of model we will go. So if there is simple linear fixed effect models, effects are available over there, then there is no such need to go to the linear mixed effect model, or there is no need to make the model complicated. So in that case, you just simply go with the linear fixed effect models. But of course, in most of the time in the real life studies, generally that predictors are available in which we just go with the linear fixed effect model. Okay, so point is, if we just compare how one model will be different for other and how one model will perform better or from the others, then if we will just say, we just consider all three models: the fixed effect model, the random effect model, and the fixed effect model, mixed effect model. So these are the three models we just defined. So first one is the fixed effect, second one is the random effect, and the third one is the mixed effect model. So in fixed effect models, what will happen? Fixed effect will be present, yes, of course. In first fixed effect will be present, but which is obvious. At the same time, random effect, it is not necessary that we'll consider the fixed effects. Okay, and in the mixed effect, both effects will be available. In random effects, the fixed effect will be eliminated. Of course, those will be not present over there. But in random and mixed effect, those effects will be over there. What kind of studies we can do? It is subject specific effects. Of course, fixed effects are not subject specific, which we earlier cleared. But in random effect and mixed effect, subject specific effects will be available. Same, what we can do with that? Can we go with the between subject variability? In fixed effect, this is not possible. Overall, they go with the overall study. So in this case, an RE and ME overall, these between subject variability can be considered. Within subject correlation, not handled by fixed effect, but it is handled by the RE and ME. And if we will call in terms of flexibility, we will say, or which one is better, if you will say, for a particular data where both kind of effects are available. Of course, the limitations of fixed effect model is very high, but where our random effect model is kind of moderate. And of course, in all three models, the mixed effect model is highly flexible, and we can get better result in terms of that. So these are kind of comparison at what kind of model we must choose when we are just going with all longitudinal data. So let's go with the next, where we are just defining our model and then we are calculating with that. Okay. So in this, if you will say, there is a linear fixed effect model for longitudinal study. So in very first case, we are just going with the simple fixed effect model, which we just defined earlier. Again, we are saying in the linear fixed effect model, assume that the effect of covariate is constant across all individuals in study. Okay, for all individuals, the effect is constant, which is that's why we are calling it as a fixed effect. The model does not account for individual differences. So we are just considering all individuals for that variable, all individuals are behaving the same. So it is same fixation for everyone. So our model will be Yij beta naught, and for predictor Xij for all individuals, that will be effective the same parameter with beta. Okay, and then epsilon ij. All these have the same, all usual notation we like that. So of course, beta naught, beta 1 are our fixed effect coefficient, epsilon ij the error term. Then we are going to analyze with the help of this. So in this model, it is suitable for the line data where individual effects differences are not primary interest. So we are not actually, the point is, if it is not in your interest that a particular variable or particular predictors is how it is impacting to different subjects, different individuals. If this is not the part of your study, so in that case, there is no need to go with the other modified or other version of the modeling. So in that case, you can just go with the fixed effect if that is not the part of your study. And it assumes that their studies uniformly for all individuals, respond uniformly to the covariates. So these are the basic structure, the thing is. And if you just go with the data set, if you will say, so we just consider the orthogonal data set where the responsible variables, we just consider the same data set in our study. And with that, we are just going with the variable. So if we will say, let me show here how it is going. Just 1 second. We share the, okay. Let me share the R software here. Just 1 second. So here this we are just sharing our studio. Okay. Share this. Okay, I think it is visible to all. I think it is visible to all. Just confirm that once. Is it visible?
Yes, sir, it's visible.
Okay, okay, thank you, sir. So here it is. Let me go in a very smooth way. Actually, as earlier I said, we are not going to the high level of modeling or advanced models. We are not utilizing. We are just going the simplest way. Okay. So before that, if you are just going with that, you can install few packages, NLME and ggplot2, which are in general, if you go with the is available. So point is, you just go with the library of NLME, library with ggplot. We just attach that data. If you will say, I will just read this data for you once, just. So we are just going to the help. We are going to the, yeah, the data is here. So actually in this data, as we just told earlier, that distance is available, age is available, subject are there, and the sex of those all children are here. So what it means, how it is, how it defines the description is, this data frame has 100 rows, of course, and 4 columns of the changes in the orthodontic measurement over time for several young subjects. So point is, the distance is, as it mentioned here, they are just taking the X-ray images of their head and of the skull, and what they are, there is a gland, and that they are trying to find out what is the distance of those glands. So over the time, how those are just we will saying is developing over the time, over the age of 8, over the age of 10, 12, and 14. So these are the values of the distance of that gland in the skull. The point is, for individual to individual, the size is different, and the increasing increment is also different. So accordingly, we are just getting the distance. So these are the variables. If you will say, we just go with the dimension of that data. 1 second. Okay. If we are just going to the dimension of this data, okay. So as it is say, the 108 observations are there and the 4 variables are there, but actually if we, for each individual, we are just considering for each individual, we are considering the observation 4 times. Okay. So overall, if we just divide this 108 by 4, then we'll get the actual number of individuals. So either we just go with the complete data, if you will say, it may give the whole data here. So here is the data. So 108 observations. So overall, if you can say there are patient 16 are marked here, and then after female patients are there, 11 patients are, if you will say female, so 16 plus 11, around 27 patients are available in this data, and as per their gender and as per their age and distance and subject, and that's what we have done with this. Okay, so here it is. Good. Now point is the same plot what we have just plot over there. If you see, you will get the plot over here. So that is the same data I just included in our PPT. In that way, age over the age over the distance, we are just calculating for each individual. For some individual, it is just starting from here. And if I can say very rough inference on the behalf of visualization, I can see or I can inference about that. Then case of female, the most of observations are looking little lower side. So the distance or for this gland may be lower for the case of female, and the male maybe it is little bit more distance in terms of female. So those are the basis of EDA. We can go with some other plotting as well, but here we just simply showing a track, how this track is looking like for longitudinal observations. Now the point is, we just go with the linear fixed effect model. For this model, there is no need to go with any particular package. The NLME package is more than enough. We are just going nothing else, simple linear modeling for this. For distance is your response variable, and I just make it clear that other two variables, age and sex, are considered here simply fixed effect models. Okay. So we are just, what we are saying, there is no impact of age or sex for individual specific. Those are similar for, or those are constant for all. So in that case, if we just going with that kind of modeling, we just give the LM and we just find out the summary of that data. So here is the summary. The all results we just calculate for a regression kind of modeling. The all results are here. We just get some estimates of course, the 17 is estimate like for beta naught estimate. Age is like beta 1 estimate. Sex is like -2 for beta 2 kind of estimate. And then all these probabilities are very low in terms of that. P values are quite significant. The thing is, all this is working fantastically. So there is no need for any other thing in terms of, if we just going, if we'll say in the very first look, everything is looking fine. So we can go with that as well, what we are saying. So before just going with that, let come to the back or slide. So this is the study what we have done in, of course, in this. We just going back to the old slide where we just left. So that how we can go with the simple fixed effect models. So fixed effect model, if you will say, there is nothing new in that. We are the simple regression kind of modeling is there. And what we have done, the linear effect model does not account the within subject correlation. What is happening within subject, that just completely avoided by the fixed effect model. So this is the, of course, limitation of that. We can go with some other model which will include this effect, and then we again go for the analysis. So if you will say, this is the next random effect model which we just defined earlier. We are just, for the same data, we will go with the another one. Again, I will just say, we have to understand where when we are going with the fixed effect, when we are going with the random effect. Here, if we will say the model one more time, what we are defining, it is Yij for the ith person, jth time. We are just considering the response variable. Accordingly, for ith variable, what we have defined, we define the beta naught, b naught, for the particularly for the ith subject or ith individual. And the same way, b1 is the impact or the parameter effect on the for the ith individual as per the Tij, whatever be the your time based over the time-based variates or predictors you just considered. That value is put it over here. So this is the simple random effect models. So in this case, we can easily can say beta naught is intercept, but is a random intercept which is subject I capturing. It will change subject to subject. Overall mean intercept is given by b naught I for particular ith individual, b1I random slope for the subject I. Now you can see as in our previous particular, if we'll say graph over there which we have shown. In this graph you can say, yes, here, that how this particular individual is going or decrease or increase or whatever it is. So if we are considering of course linear model here, so we are considering those are going to be linearly increasing or decreasing. That will define by the beta naught, and what will be the rate of that will also be defined by b. So all those character of individuals of subjects will be captured by beam. So that's why we are defining this model over here, and this will be subject specific. That's why we are saying subject to subject will going to be changed. So we are just defining random effect model in such a way. Epsilon ij will be defined as per the terms b naught and yij. So this is whatever be the variability in terms of residual error, we are just considering with the help of this epsilon ij. So this is my random effect model. So if first we just consider the fixed effect model, now I am considering the fixed effect. First one we just fixed effect model. Now we are going with the random effect model. So in that case, there is very little changes, but what we have to do over there is, okay, what we have just considered, we just considered age as a variable of interest. Is treated to follow up time points. Whatever be the time points over that, this is going to be changed, and b can be defined. So that's why we just consider age in this case, which is lacuna. Actually, we will say in the previous model where we just consider the fixed effect model, but in this case, age is over random effects over which we are just going to find out the values. So that is our random intercept and slopes. Accordingly, we just define the model. The same, we are just going the LME here. Okay, and if you will say, I can go with the R software. Let's share the R software here. Good. So if we are just going the fixed effect model, now in random effect model, what we have done, we now done nothing special here. We are going with the LME models. In this case, no fixed effect, as I'm just saying, taken. We just consider the intercept, which is like B naught I, and the second is age is considered as a random intercept. Okay, and slope. So on the basis of age, it will consider your B naught I and the B1. So these two parameters will be calculated for this. There may be some other variable if our data will be more dimensional. There will be more other variables will be available over there. Then we can include those over here. Not is then any other random variable. If a random effect is available there, then we can also add that also in the mode. So that will be beta naught, B naught I, B1I, and like B2I. So these 2 or 3 parameters will be estimated with the help of that. So in that, we just consider the same data and we just see the summary of that. So here is the parameter estimate. Accordingly, our model is looking like this: AIC, BIC, and log likelihood for the same data. The different model we just considered. So in this case, you will say our parameter estimates are 6 point for the intercept, 0.69 for the particular B node, B1I, and accordingly. So the point is these are our overall effect for the B node I is say just shown over here, and of course within group we are just going some distances are calculated. Fixed effect, in the fixed effect model, it is defined in the terms of value, standard error, and all these things, or intercept terms. But standardized within group residuals, if we just say, we have just shown some summarized form of the standardized form point of view. So the thing is, the basic is there is no such needs of any kind of special syntax or programming over there. There are well defined basic models are available for fixed effect or random effect modeling. But the point is, if we have a real data, then for that particular data, we must be identifying that which particular variable is going to be which kind of impact or effect on the response variable. So accordingly, we have to identify that. So if we'll just say, actually in the last of this section, our main motive or purpose is to identify or to reach to the last, which is we are saying the linear mixed effect model for longitudinal study. So actually we are interested in this from very first. We are just going to why by step we are approaching to that. We just seeing when we can use fixed effect, why we are not using fixed effect, we are going with the random effect, and then lastly why we are just using this random effect, why we are not mixing both of them. If the data in data there are some predictors are available which can be treated as fixed effect and some of them are from the random effect, then of course we must go with the mixed effect model. And if the information is available, then that model of course will give you the better result, or better precise results. Okay. So the linear mixed effect model is what we have said earlier, that effectively capture and analyze the heterogeneity of longitudinal data, provide accurate and insightful results. Of course, the point is we just integrates both. In this linear mixed effect model, we integrates both. We integrate fixed effect model, we integrate random effect model. Both kind of effects are just integrated over there. And what it does, what specifically it does, it accounts both within subject correlation is considered, subject specific variability is also considered, person to person how the observations are just varying. That is also the purpose of any modeling. How one person is behaving for the same kind of treatment, how the another person is behaving the similar kind of treatment. There are number of predictors are available. Maybe the female and male are the response or the growth is different for the same treatment. So that all these kind of things comes under the linear mixed effect model. Okay. So what is special what in this model is? So the special thing is how we will define this model. How we will capture the both in the sense the term of fixed effect and the terms of random effects. So what we have done, the same response variable yij is here, and we consider the same predictor, say xij, with some beta. Beta is of course our fixed effect correlation, and at the same time in this model we are adding some other predictors which we are calling as random effect, or those are just regulated by bi, and bi is of course our random effect coefficients or in terms of parameters. So now both kind of parameters beta and bi are involved here in a single model to capture the both kind of effects available in your data, and accordingly the predictors will be utilized. So this is the overall purpose, to utilize the linear mixed effect model. So in this case, all these things as usual, which we considered earlier, yj is your outcome variable for ith subject individual at the jth time. Okay. Xij, a vector of fixed effect covariates, the covariates which you considered in your study, that those are fixed effect covariates. So you just take all this or those predictors in your study and just they are regulated by beta. Then beta is your fixed effect coefficient or parameter. Then you filter out zij. Zij is your random effect covariates for ith variable at jth time. That is one thing. And bi is a vector of random effect for subject I. Those it is defined for the particular one. Then epsilon ij. So here bi is a defined for individual to individual. Then epsilon I is a overall residual error term for subject I and time j. So what I have done in the the point is what are the basic assumptions which we are just defining here one by one. Of course, we are going with the linear modeling, so it is linear assumptions will be there. For the random effect on the very basic level, which simply goes with the normal distribution, you can see here we just defined it is in the terms of sigma b. So it is in kind of a multi-dimensional. This kind of a matrix will be over there. So I will define this in the next slide. So residual error will be accordingly defined. It will follow normal U sigma square. Independency is there. Homoscedasticity is there. This will be the residual will be constant over the over the all predictors that we are just considering and the time. So these are the basic 5 assumptions in general we define in the terms of any regression analysis or linear regression analysis. So those are somehow generalized over here and utilized in case of linear mixed effect model. So the point is, what I have done, I just try to make it quite simple. As per our data, I just try to break this in again in the previous models form. So what I have done is, say Yij is your response variable, okay. Then beta naught and beta 1 is your parameters as per fixed effect model. Then Tij is your accordingly the covariate or accordingly your predictors, which will define as a fixed effect. Then what we have defined, we define a B naught and B1I for Tijs. So this may be defined Ti in different ways. So there is a little bit of split here. So the point is, these are defining the random effect parameters and then epsilon ij. So here what we are saying, so in terms of B naught I and B1I are the random intercepts of the subject I, and again for the ith one that can be put in the terms of this, and these two again will follow normal distribution with some variance covariance matrix in terms of sigma. So it will be in terms of say maybe 2 by 2 is in this case. So that kind of a bivariate normal distribution will follow. So that's how it is defined for the individual basis. Subject basis we define this. So that is the overall expanded form, if we will say, for the linear mixed effect model, which can be understood by simply the terms of this model. So if we just go with the, okay, before going to the R code, let me just finalize the things here. The maximum likelihood we can consider, of course, there is no issue with that. We can also can go with the restricted maximum likelihood. It generally we call in the REML in terms of okay, the point is what we are trying to say, the maximum likelihood estimation and restricted maximum likelihood estimations are both are used for the same estimation of the parameters. But here what we are considering why we go with the MLE, why we go with the restricted MLE, what are the advantages with that? Actually, what the restricted MLE say, if we in some way, I will just try to just define how those are different from each other, or what is the how we can compare both of them, and why we use the MLE or why we use the RMLE. So I particular this slide is dedicated to that. That MLE, as we know, estimate both fixed and random effect parameters. Okay, no issue with that. MLE can lead bias estimates of the variance component, because it does not account degree of freedom of the estimate the fixed effects, and can overestimate or underestimate variance components. So it is actually not conditioning that thing. But once you are just restricted in terms of maximum MLE, so in that case it provides unbiased variance components, which is required actually in terms of once you are considering the random effect, you are taking beta naught in terms of sigma. So in that case we have to find out is it unbiased or not. So what it is doing, it is just variance component by conditioning the fixed effect. It is calculating that once the fixed effect are conditioned, then we are just going to estimate the variance of components. Then this focus only on random effects, adjusting for the degree of freedom for the fixed effect. So point is, in MLE, it is going directly for that estimation of all parameters. And in terms of restricted MLE, that's why we are calling it is restricted, because it is just fixing first, conditioning first the fixed effects, and then it is going for the estimates of the variance. So these two both methods, if I will say MLE and RMLE, is available in simply the same command. You just have to give the method, by which method you are just interested to calculate. So yeah, here is the I think the last slide of my today's presentation is that, okay, we are just going with the say R software. So let me just share this slide of R Studio. Okay. Good. So in linear mixed effect model, we just seen earlier that The term is we just going the model. In this model, if you will say, we just not define any method over there, and it is run by here. So I will just show the comparison between them. Our data is same. We just calculated AIC, BIC, and all these things, and you will say the AIC, BIC are lower than the random effect model in this case. So it is somehow doing better than that. And intercept, we just find out the estimates for intercept. We just find the A's and all these things. In that case, fixed effect models are considering in terms of A's, and overall we just find out uh, the results in terms of, say, intercept of age is calculated over there. And if we just interested to find out how it is working here, so in the next one, what we have done with the using the model ML, what we are saying earlier, that we just consider the method ML here over there, and then accordingly we are just going with this. So what we are saying, we are just consider ML model, particularly if you are taking no method over there, then this will be work simply. But once you are just introducing the method is equal to ML, then it will calculate it over there. So what will be the advantage of that? If you will say the term of, okay, this is a simple fixed effect models, or intercept and A's are like this. And if you are just going with the random effect terms, then your variance terms in which we are just interested to show will be look like this. So this is the basic difference between both these. Once we are just going with the fixed effect terms of point of view in the same model, just terming that your estimates will be look like this. So these are nothing else, simply if you just try to remind our model, then these are beta naught and beta 1. Okay, as a fixed effect, how it is defining the beta naught beta 1. And in the second case, in terms of that, when we are considering it is a random effect, variance components will become for both with intercept this and with ACE values this. Accordingly, if we are going with the ML procedure, the second method we just conditioned over there, in that case it will be 4 point something intercept in terms of 0.46 for the 46. So here the difference is very low. Otherwise, it is in general it is considered that the case of REML, the variance terms is quite lower than the ML estimates. For the simple data, it is almost similar. So in that way, we can go with to identify or fitting our model. Our purpose is just to find out the estimates of the parameters. So here the parameters are available. So the thing is, we can go with any of these methods which you are think that it are better for I can say in terms of your data. If you are just working with the longitudinal data, just go with that, and accordingly consider in what kind of you are interested to utilize that. Actually, no one knows better than that, better than you, that which particular predictors you can utilize as a fixed effect or random effect, or accordingly what kind of model we can go with that. Okay, so these are the basic things. I will say again, I'm saying this is the very simplest way, very basic models which we just go through today. There are a number of methods, and as per the character of the data, as per the scenario, as per the study, we just observe the data. Accordingly, we have to choose a model, and then we just find out the estimates on the behalf of that. So I think it is a little early today, but this is for all from my side. These are few references, if you will say. The first one is more than enough for the who are the beginner. The analysis of longitudinal data. I think once if you just read this, you will get all the information, all the basic information, or you may get a third one, the package which we utilize over in this R coding. So thank you from my side. If there is any query or anything else, you may ask.
Dear participant, you can unmute your mic for your question. The session is open for discussion.
Good evening, sir. I'm Dr. B. Basu Malik. So I want to ask a question, sir, that whether this restricted maximum likelihood estimation, which you told, will give you a much better longitudinal analysis as compared to the maximum likelihood estimation, or will the error will be minimized in this case of restricted REML or than the normal maximum likelihood estimation that we do? And why it is so actually? I mean, what is the reason for that? I mean, is there a particular reason? Hello?
Sir, you are muted. Please unmute mic.
Okay. Now you can hear me?
Yeah.
Yeah, okay, good. The point is, that's why I just put a particularly slide for that in my slides. The point is why we are just going to the restricted MLE. The actually purpose is what, when you are just going with the ML estimation process, in that case, all parameters are equally considered. So there is no that kind of restriction. That's why it is put restricted. But in RMLE, what it is doing, but first it is just fixing the impact of your fixed effect parameters, and then it is going to estimate the second one, the random effects. And the purpose is to minimize or to optimize the variation in the variation in the estimate. The point is, in general, if you will say in statistics, we are going behind the two things when we are estimating. The first one is we are just going to estimate, of course, either it is unbiased or in terms of that. And the second term is what is the variability in that. So once it is the B is, if you will see in your model, the B is changing or defined on the basis of individuals. So how all those over the individuals, what kind of variability it is taking, that is also with the point of consideration. So that's why we are particularly going with the restricted MLE. So actually our data is quite simple. There is no that kind of impact of random and or fixed effect. So the results are almost similar. But in realistic data, if you will go, then you will find the impact of course, restricted MLE. So you will get the better result, improved result in terms of RMLE, and there is nothing special to calculate in the software. Either you use by default it use a RMLE. If you are particularly interested in ML, then you just put a method is called ML. Okay, doctor.
Okay, sir. Thank you. Understand. So that means by RML we can restrict the variability of the series data, as isn't it? And if I restrict the variability, the error will be minimized.
Yeah, in other way, I will say in RMLE, we just condition the fixed effect, and then we check, then we try to minimize the variability of the
variability
random effects. Okay.
And it becomes more unbiased estimate. It becomes a more unbiased estimate.
In likelihood estimate, it is, of course, we go with the unbiased estimation property. There is no issue with that. Okay.
Okay, sir. Thank you, sir. Thank you so much. Thank you.
Okay. Yeah, is there any question? Himanshu Agrawal is, I think, writing something, sir. Can you make clear on carryover effect and period effect while dealing with the repeated measure? Okay. You use your own terms, carryover effect. Yeah, Himanshu, can you unmute and please describe what you are actually interested to ask, Himanshu?
Hi, sir. I'm Himanshu.
Hello.
Am I audible?
Yeah, you are audible clearly. Okay.
Thank you, sir. Sir, I want to ask, like, we have a carryover effect, like, baseline we started, right? Just suppose, like, on 0 day, we started by just measuring the weight or height.
Okay.
Right. After 7 days, again, we will measure. After 14 days, then there will be a carryover from baseline for 7th day to the 14th day.
Okay.
So how means you can interact with that thing? How means it will give the bias mark or some kind of thing like this?
I did not get exactly what exactly your point is, but the point is, let me improve your data first, then we will discuss about their interpretation. The point is, if I will say the terms of baseline is that
Yeah.
okay, you are just saying that sex may be considered as a baseline variable. Okay, so at the very first
Okay.
day, the time of entering in the experiment, that is fixed in terms of that. Okay, and then what you are doing, you are over the time, say per week, if you are saying you are collecting data. So after first week, you just take some parameters of in terms of patient, it will say. You just take the data of their different parameters like BP, what is the value BP, how it is going to be, or some other hemoglobin is there, or platelets is there, in like that.
Hmm.
So that you are
I fully
collecting
agree.
after 1 week, 2 week, 3 week, and 4 week. So
Yeah.
whatever be the, say you just diagnose the particular disease, for that you are just collecting that data. So now few things are which is baseline, which are in some way is not varying over the time. Okay, and
Yeah.
few things are those are impacting or just behaving over the time, and you are expecting that those things will impact on that patient to recovery. I can say
Yeah.
quite easily. Okay, so like in general terms, we say that the pattern of platelets will tell significantly how the patient is recovering or not. Okay, so the point is, there are some variable which is fixed effect over there, kind of gender or may other some available, but some other things, those parameters are randomly taking their some changes, and those are changes at the same time for individual to individuals with the
Yeah.
same two patient with the same sex may change behaving different for the plate changing of the increasing of the platelets or at the different hemoglobin level. So in that case, now it is the duty of the, say that the doctor or whatever you say, he will identify on the behalf of which we are going to make some analysis or predictions. Of course they do on the behalf of their practice, they are not going with the modeling. They can identify on the basis of those variable what is going to be happening. Okay,
Okay.
so
Yeah. Yeah. I
those
fully-
variable which are on the time varying variable over the time, those are behaving, and those variable of course baseline like male or female, so they can identify what is happening with the male with that kind of platelets and what can happen with the female with that level of platelets. So all these things or these two effects will come together, and then you can diagnose or inference about the particular. Is it clear?
Yeah. Yeah.
Good.
Yes, sir. Thank you, sir.
Okay. Anyone else? Dr. Meherjan, I think.
Yeah, anyone, if you have any question, please. Roshni Kumar, Sajal, Sahil, Pooja. Okay. Dr. Uttam, I think there is no more question. So thank you, dear professor, for your valuable time. Heartfelt thank you to our professor, resource person in this session, for delivering an insightful and valuable presentation on longitudinal data analysis. Your expertise and clear explanation of this complex topic have enriched our understanding and will surely benefit us in our future research endeavors. We truly appreciate the time and efforts you took to share your knowledge with us. Thank you for making this session so engaging and informative. Thank you, dear professor, once again, and thank you to all the participants. The content which has been presented during the session will be provided to you very soon, and do practice on it. And one more important information, our one session is pending. That will be held on 30 on Sunday evening. So the information regarding will be shared in the WhatsApp group also. So once again, thank you to all. And on Sunday, we will join at the same time. Thank you to all. Now we are going to end the session.